This lecture video covers quantum gravitation, specifically the interaction of electromagnetic EM fields along with the force of gravity as defined by Newton, all explained using Tetryonic geometries, or the equilateral geometry of energy at the quantum level. It follows on from the previous public lecture where I covered spatial geometries along with the definition of mass, energy and matter, and how tetrons, or the quantum of matter, creates the force of gravity through its interaction with vacuum energies. If you're not familiar with these topics, I suggest you go back to the previous video and go through the lecture on that so that you're thoroughly conversant with the definitions of mass, matter and energy, and how quantum energies interact with matter and are created by matter. We'll now move on using equilateral energy geometries to explain the lines of force, the laws of force, and how special and general relativity erred in their mathematical formulation of Lorenz's correction or velocity corrections, and by applying them to matter as well as mass. And this arose purely because Einstein's formulation in special and general relativity could not distinguish between EM mass, energy, and matter, so they were all put together as a energy density within the same spatial coordinate systems in a stress energy tensor in the case of relativity. Gravity, or the convergent force between two forms of matter in space or even on Earth, is one of the four fundamental forces of nature. Electromagnetic forces and strong and weak nuclear forces have obviously been touched on in previous lectures and are covered in more detail in my previous ebooks. What will be shown now is through Tetronic geometry and the distinction between mass, energy and matter is the geometry that underlies both Newton's formulation of gravity and that of Einstein's general relativity in his formulation of gravitation. You'll note that I used the word gravity for Newton, and gravitation for Einstein's general relativity. It'll be shown as we progress that one is a strictly convergent force acting between bodies of matter, whereas general relativity will be shown to be a net force generated from three differing forces acting between bodies of matter. Galileo was the first, or one of the first, in our recordings to begin to describe the ideas of gravity and gravitation. He apocryphally did it by dropping balls from the Leaning Tower of Pisa, and then things like rolling balls down inclined planes. But he nevertheless formed the foundation for motion, and in particular the motion of bodies under the force of gravitation. Sir Isaac Newton was the most famous of the people that have formulated gravity or gravitation to date. He did so through the measurement of momenta, or forces between two bodies, and simply developing an inverse squared law between two bodies of matter, or mass matter. He then derived a constant that would explain the motions of the bodies as they moved and had been observed by Kepler. Roger Bosovic looked at Newton's work, looked at Coulomb's work, and proposed that maybe it's just a diminishing EM wave that creates gravity. Of course, noted is the fact that Newton, although he mathematically described gravity or gravitation between two bodies perfectly, or within his scope of measurement, he was unable to explain what caused gravity between the two bodies. Roger proposed that it was just an EM wave that spread out from the bodies and caused the interaction that created gravity, much the same as Coulomb's inverse squared law spreads out between bodies and creates a force interaction, although in the case of gravity the force was always convergent, whereas in the case of charged bodies they were interactive. As explained in Tetryonics, quantum mechanics and QED, it's now been retermed the law of interaction, because in the case of charge you can have pushing or pulling. However, in the case of gravity it is strictly convergent. It always pulls to the center of the body concerned. Carl Gauss applied mathematics to the problem, again erroneously using 4 pi spherical geometries in calculating his solutions. They work extremely well for planets and their satellites, as noted on the top right, and they also work well for charged objects, protons and electrons, as noted on the left. However, in both cases the 4 pi geometry is now shown through Tetryonics to be a tetrahedral geometry, not a spherical, although on large scale matter like planets, obviously the equilateral geometries tessellate, or the mass energy of the geometries tessellate to form large scale matter geometries, which can in fact be generalized as 4 pi spherical geometries. He of course noted that the formulation between gravitation and electric charge interaction was identical. It's the same thing, and from that occasionally you'll see references to gravity being a charged interaction. Tetryonics strictly defines a charge interaction as either attraction and or repulsion, whereas gravitation is strictly convergent, as is always noted. But the forms mathematically for both charge and gravitation are indeed similar. It's their constants that change. Again, additional formulations in the way of energy flux or energy density, electric field permittivity, out from positive charges, was applied to the case of gravity to see if there was any way that perhaps the mechanics and the formulation of electric and magnetic fields could explain gravitation. Mathematics proved to be a fine way for structuring the interactions and the forces involved, but it provided no clues as to how to drive things further forward and what was possible. And this became even more evident when Maxwell attempted to unify the gravity and electromagnetism together in Gravito-Electro-Magnetism by simply exchanging the forms of electric fields for gravitational fields, and in which case he had to come up with a magnetic field that diminishes as 1 over the cube of the distance of magnetic dipole. Of course, there are no differences between the fields, gravitational fields of a body. They are all inverse squared laws, and that's where that hit a stumbling block so far as unification, unifying gravity as a form of electromagnetism. Einstein then applied his special relativity work that he'd done in 1905 to the task of accelerated bodies, specifically gravitational fields or matter within gravitational fields that are constantly accelerated as they approach the bodies, in an attempt to use special relativity to create a more generalized formulation for accelerated bodies. This led him to general relativity, as it's named, and a formulation where the energy density of a measured volume of space, or a measured region, the curvature of that region, or the energy density of that region, can be calculated and gives him the similar results, if not the same results, for Newtonian gravity. However, it's much stronger as it approaches the source of the gravitation, leading him to a erroneous deduction that strong gravitational force will indeed bend light close enough to it. This then led to more erroneous discussions down the track on the mathematical applications of relativistic formulation of gravity. It left us with two competing laws of gravity, obviously Newton's gravity and Einstein's general relativity. Mathematically different. Newton's describes the force between two objects, whereas Einstein's formulation says there is no force between the objects. The bodies move in the path that they move because of the changes of the energy density within those regions of space. In the case, the other standout point is, even though Einstein's general relativity includes Newton's gravitational constant, it in fact has a stronger gravitational field closer to the larger bodies than Newton's, and diminishes to Newton's standard formulation further away from the bodies. This was particularly important when it came to mapping more accurate measurements of the motions of bodies such as Mercury in relation to the Sun, and comparing it to Newton's formulation. Newtonian gravity, as such, describes an action at a distance, an instantaneous one, between the source of between the two bodies involved in the gravitational interaction. This interaction happens instantaneously from one body to the other. Our planet orbits the Sun based on where the Sun is now, not where it was when light was first emitted from it. However, special relativity precludes anything travelling faster than the speed of light, as formulated by Einstein, and it was a major foundation in general relativity. So Albert Einstein was unable to accept the fact that there could be any form of action, instantaneous action at a distance between two different forms of matter that were gravitationally attracted to each other. This led to his development of curved space-time, energy densities within his formulation, and led to people trying to detect gravitational waves from the Sun to Earth and from other planets or supernovae as they interact with the Earth. One of the things that comes up as a common term in general relativity is folded space-time or curved space-time. Space-time itself has to be redefined, as was done in the previous lecture, as with respect to the energy density of a region, or the vacuum energy density of a region. It should not be a curved space energy density, or the changing energy density of any vacuum energy of a region should not be confused with the folded space-time energies that energy folds into to create standing wave matter forms. They are distinct things and they operate differently. However, they are all based on equilateral energy when applied through Tetryonics. And in fact, as noted there, electromagnetic waves comprised of even energy geometries with opposing momenta can in fact, in the right form, create instantaneous action at a distance through their momenta or energy momenta. As a transverse wave they cannot do this, but as a longitudinal wave they can in fact create an instantaneous force between two matter objects through their radiated energies. Again, from the previous lecture, matter itself as a standing wave energy form in Tetryonics is shown to have a zero energy density within its geometry. The quantum geometry of all tetrons that form matter are tetrahedral mass energy forms, geometries, and they exclude all energy at all wavelengths from within their geometry, creating a quantum Faraday cage, if you like. This excluded energy creates a region of zero energy density within all matter geometries, as indicated in the middle picture, and re-explained as an energy density in the lower middle picture. And as tetrons form larger and larger scale matter, these zero energy interiors of the tetryon create larger and larger accumulations of zero energy density. As the surrounding vacuum energy impinges and tries to equalize that energy density, as it always will do under the second law of Tetryonics, it creates a strictly convergent force, and that force will remain as long as there is a matter geometry remaining with zero energy inside it. Upon the collapse of any matter geometry, energy can obviously then be equalized, and the standing wave matter energy will radiate out as a mass energy or as photons or charge. Again, the middle picture simply highlights the zero energy densities being impinged, of matter being impinged upon by vacuum energy, creating gravity. And again, the same thing is drawn here at the bottom of the middle, where we have the energy density, or rho, of matter, obviously containing zero energy densities themselves, but as a matter energy density itself, or its mass energy, can be measured or calculated as a general relativistic stress energy, is in fact impinged upon again by its surrounding vacuum energies, creating a gravitational or a convergent gravitational force, which is always attractive, highlighted in dark green arrows, as opposed to the radiated or blue arrows, which radiate in both directions, indicating interactive blackbody radiation or electromagnetic fields that all matter, particularly matter in motion, will create. Any matter in motion or any matter standing still will radiate blackbody radiation, energy, heat, light. Any matter in motion will also have a chem field or a kinetic EM field generated by that motion, which again has interactive or divergent and convergent energy momenta. All of these divergent and convergent forces, along with the mass energy matter density and forms of energy where the interaction is taking place, or the center of the spatial coordinate system, must be taken into account in order to create a quantum theory of gravity, or gravitation specifically. With modeling the force of gravity, obviously both gravitation and Coulomb's charge force of interaction can be modeled tetryonically as the diamond created by superpositioned chem fields or charge fields of charges or matter in motion. In both cases, their radiated fields will superposition in a region between the two bodies, and in that region a square, an E squared or an energy squared, chem energy squared field will be created with opposing momenta, and these momenta will exactly indicate the direction of force between either the neutral masses or the charged masses in the case of charge. And in fact, that's the geometric basis for both Coulomb's force law and Newton's gravitational law. In this case, the geometry of the charge fields and the gravitational fields give some hint to the fields of interaction between the two bodies, and some hint as to what's creating those forces. In this case, it's the energy momenta within the diamond areas of those fields. Throughout Tetryonics, most of the time you'll see charge being drawn as orange, in this case orange Q's for charge, net charge, and orange charge fields of interaction. In the case of gravity, matter is drawn as green, and the gravitational fields as a darker version of that green. So the gravitational field between these two matters, between matter 1 and matter 2, is the green diamond, and that is an inverse square field of which simply results from the superposition of two charged or two radiated fields of energy from the bodies. You will note that the magnetic fields in both cases do not provide any interaction or any force interaction between the particles. It's strictly an interaction through the kinetic energy fields or the electric energy fields of the chem geometries or the matter geometries. We've gone through this before. You can, in fact, now that we've explained what inertial mass is, as in the breakup of convergent and divergent energy momenta within all square or equilateral energy geometries that form mass energy within matter, we can, in fact, designate all convergent energy momenta as a way of modeling gravitational mass. And in fact, they will be equal in both cases, whether you draw them this way or geometrically, or whether you model them mathematically the same way. Again, highlighting for those of you that haven't been through quantum mechanics, that mass velocity squared, or the energy of a system, is also equal to Planck's constant quanta squared, or Compton frequency, the square of the quanta, which is always a square number. The energy of that system per c squared, or per spatial geometry, being a mass, will give us the mass of the system. And they follow and generate Newton's second law, F equals ma, purely from the geometry of the energy momenta quanta within each squared energy field. A larger version of this time showing that convergent or accelerating forces on a body can be marked as convergent force upwards, whereas the gravitational force is always the convergent force. Let me say that all again in case I did mix it up. The divergent force can be modelled as a accelerating force on a body, in this case an elevator, moving it upwards. The convergent or downward force can also model the gravitational force that exists on a body in a gravitational field. So in this case we have an elevator with a force, be it a rope pulling it upwards or something underneath pushing it upwards. In either case there is a force moving it upwards, and it is fighting against the convergent force of gravity pulling it down. In the case of a large generalized 4 pi matter body, that convergent force is always acting to the center of the body, and you'll find that in fact acceleration can be modeled with divergent energy momenta, and the force of gravity or the convergent acceleration can be modeled with convergent energy momenta in the same field. Interestingly enough, the weak equivalence principle says that the inertial and the gravitational masses are equivalent, and in fact, even though it's not shown in this diagram, the inertial mass affected by acceleration and gravitational masses all result from the plus and minus charges of any energy field or any charged energy geometry. So therefore, as they result from the total quanta within the field, they are in fact the same. Each quanta contributes to the inertial mass of an object or matter, and each charged quanta contributes to the gravitational force on a gravitational mass on a body. Newton's laws all focused around momentum or change in momentum, mass, velocity. In doing so, all three forces can be rewritten mathematically and drawn geometrically within Tetryonics. Newton and his formulation, however, relied on an almost instantaneous force or action at a distance between the body creating the force and the body responding to the force. And he could not explain how this instantaneous force was firstly created, and secondly, how it was propagated through space, and that's what led Einstein to developing his work based on special relativity and developed general relativity. In fact, Tetryonic electrodynamics goes into great detail the geometry or the energy momentum geometry of electromagnetic waves, and shows that longitudinal waves, or the waves that Tesla was developing with his technology, are in fact capable of having all their energy momenta, which, and the momenta being just the square root of each energy geometry, lined up one after the other from their source of propagation to where they're received. And by having these energy momenta lined up back to back, face to face, as they propagate, once the energy field is established between two objects, any change in the source, so far as the strength or the amount of energy momenta, voltage if you like, per second along that field will be instantaneously propagated by virtue of these connecting momenta, rods if you like, to the other end at speeds faster than light. And is this arrangement of energy between the sun and the earth, or different bodies of matter, that facilitates Newton's instantaneous gravitational interaction. In fact, it will be shown not to be an interaction of gravity, but it's an electromagnetic interaction that forms part of gravitation. Gravitational acceleration, again, can be drawn as the accumulation of the convergent energy momenta, or energy forces, momenta forces, acting on a body inside a gravitational field. It can be drawn out in various ways, as illustrated there. Where the fields interact and create a gravitational force, it is the result of a superpositioned two fields, one from the smaller body, one from the larger body, or equal fields if they're both exactly the same mass matter. In both cases, the energy momenta generated by the amount of mass, the kilograms, simply becomes squared in the superpositioned or the diamond part of the field where the gravitational interaction takes place, to give us Newton meters per kilogram squared. Obviously, if one mass is larger than the other, there is an offsetting and a shift in the center of gravity between the two bodies. All these fields, when you map them, are in fact identical to the mapping of the electric fields between two charged objects. As noted in this illustration, the formulation between Coulomb's law and Newton's law is identical. The difference comes about, even though the formulas are identical, that the gravitational constant created by Newton is far weaker than the gravitational force created by two charged objects that Coulomb measured. Had Newton been aware of charge and done experiments the same as Coulomb, no doubt he would have noticed the similarity. He may have even predicted the similarity had he known about charge interaction. He would have just said, well, it's going to be an inverse square law, it's going to follow the same mathematics. In this case, they follow the same geometry. Each charge, or each body of matter, which again is just made up of charged geometries, creates a field, or can be represented by a field, of x Newton meter per kilogram, in which case the region of interaction is a diamond shape, a inverse square law, and the strength is determined purely by the squaring of these two forces, again represented by the energy momenta directions of arrows. In the case of charge, positive and negative will attract, similar charges will repel. In the case of gravity, they always attract. Again, highlighting Newton's gravitational constant and the geometry between two objects of mass matter and the gravitational field that they create with the acceleration due to gravity being reflected by the energy momenta in those fields. Obviously, when you think about it, even though they're neutral, all these mass matters are created of charged masses, and their electric field will also have some bearing on the interaction between the two bodies, as will their gravitational field. What happens though is that the electric field, being stronger, plays a role more at the quantum level than it does when the distances are greatly separated as they are between planets and stars and the like. But again, they simply follow Newton meters per kilograms, or force per equilateral geometry representing the mass energy of the matter involved. You'd simply calculate the mass energy of the Earth and then just draw an equilateral triangle. Similarly, you would calculate the mass energy of the Moon and draw an appropriate triangle scale to that. In this case, I've drawn them both the same. They, while the fields are identical to each other, the Compton frequency, or the number of quanta within each field, would be vastly different and would in fact be proportional to each other by their mass matter. It's easy enough to calculate, and in fact that is what Newton did in calculating the force of the gravitational constant. He simply calculated the mass matter differences between the mass of the Moon and the mass of the Earth, and that gave him the strength, the proportionality of the strength between the two. He didn't have to measure the weight, and in fact that's what Cavendish did in all his subsequent experiments, was purely to calculate the exact mass of the Earth's matter. The gravitational constant, therefore, can be drawn simply as a diamond-shaped superposition field, or the diamond-shaped field of interaction that results from two chem fields that interact. In this case, the chem fields represent the mass energy of each matter. From there, you can then calculate the energy content for those fields and the level of interaction, how much pull in the case of gravity occurs towards the Earth versus that of the pull towards the Moon. In both cases, there's an equal and opposite reaction as per Newton's law, and the strength of the gravitational fields is proportional to the mass matter of each body that interact via the gravitational forces. The center of gravity, as I've mentioned, as you calculate the mass matter, or the mass energy of each matter, to determine the field geometry and the energy quanta in that geometry, the fields will have differing strengths, or differing Compton numbers of quanta within those fields, and obviously each quanta has equal energy momenta, so the differing number of quanta will create a different level of attraction between the two bodies of matter. And as I mentioned before, in addition to the strictly gravitational force at a distance, there also remains an electromagnetic force, which again is an inverse squared force around the body as well. Mapping gravitational force and comparing it to Coulomb's force is exactly the same geometries. The only difference between the two is in the strength of the field of interaction, Coulomb's constant being far greater than that of Newton's gravitational constant. Obviously, if the energy levels are different between the field to the different masses, the center of the field will adjust accordingly. In Tetryonic chemistry, we showed the structure of all periodic elements and displayed what the atomic nucleus looks like in reality, as opposed to the various models that have been drawn over the years since we first started delving into the atomic nature of things. Now that we've fully described the charged geometry of all matter, and we've described the exact geometry of all the elements, it's clearly shown that the 4 pi spherical geometries that have been used were in fact rough approximations of the 4 n-pi geometries of tetrayonic matter, in this case all elements. They can be generalized as 4 pi, however as a point source, if you want to develop quantum gravitational models, you have to have an understanding of the quantum geometries and the null spaces that matter creates within their geometries, and the accumulative effect that this has on gravitation itself, plus the equilateral energies that each matter geometry creates in the way of blackbody radiation, and additionally electromagnetic fields generated through their motion in vacuum energies or in space. Newton's gravitational laws traditionally have just been defined as applying to neutral masses, whereas Coulomb's laws of force apply to charged geometries. Tetryonics obviously shows the difference between a charged matter object and a neutral matter object by virtue of their geometries, and again shows that the mass energy content of both is simply a measure of their mass. What Tetryonics then does is it explains gravitation as vacuum energies seeking, or gravity as vacuum energy seeking to rid matter of its null energy interiors, so it impinges on this generalized 4 pi geometry in a always convergent manner, seeking to equalize those forces. But in addition, all matter geometries will create either a charged geometry between them, if they are charged matter geometries lacking neutrons or lacking electrons or having excessive electrons. And as this force of interaction is identical in geometry to the gravitational interaction, but of a differing strength, at the quantum level, it is the electromagnetic force that dominates over the gravitational force. And conversely, as the particles separate further and further from each other, the electromagnetic force weakens as the square of the distance from the particle of matter. However, because gravity is the result of the vacuum energy which fills all of space impinging and trying to get rid of these zero energy null spaces, that energy source is always there, even at vast distances from the matter itself. So as the objects get separated further and further, this force begins to dominate, whereas the electromagnetic force between the matter is dropping off because of the inverse of the square of the distance. And additionally, now that we can define mass as being a measurement of energy in matter, we can now define mass matter as being different properties of energy within differing geometries. As an example, uranium would have vacuum energies impinging in all directions on its charged geometries, and if you were to pull the uranium atom apart into its constituent 92 charged deuterium atom, each of differing energy levels, you would find that the vacuum energy would continue to act on the individual null spaces within all these geometries. Electrons having 3, protons having 9 tetrons, and neutrons having 9 as well. Matter would continue to act on these individual null spaces or matter geometries, but in fact each of these matter geometries have electrons with spin, and these electron spins all accumulate along with the motion of the matter particle itself and its chem field to create an electromagnetic field. So if you want to model gravitation, or the attraction of one body of matter with mass energy towards another body of matter with its own mass energy. On the quantum level, you have to not only define gravity as we have just done, but also distinguish between the gravitational attraction, convergent, and the interactive attraction, or the interactions of black body and EM radiation generated by that body and its motion. Tetryonics allows us to do this, whereas general relativity and special relativity simply lumped matter, mass and energy in all its forms into a density field and plotted it as a curvature without distinction between any of the forms. Again, highlighting in this case that electrostatic fields can be either two negative charges or two positive charges. In both cases they have divergent and convergent energy momenta, with the total or the net field always being a net divergent force. If you add up all the divergent charges, you'll see that they outnumber the convergent charges, making a positive charge in this case. And if these charges were separated, you would actually make an EMF, or two separate voltages, again divergent in nature. Whereas gravitational fields can be modelled as they were with Newton mathematically, but they can also be modelled geometrically as convergent only fields moving back into a source of neutral matter that's static. The fields will always converge back down. So again, you can redraw the point particle of matter as having convergent gravitational fields and net divergent charge fields. So all the energy momenta of the charge or chem fields add up to be a net divergent force that always radiates away from the body, even though they can provide an interactive force between them. Whereas if you were to model gravity, you would model it as a strictly convergent force attracting to the center of the matter, as drawn here in dark green. So this central picture shows a body of matter with its divergent EM fields and its convergent gravitational field. Likewise, this is a charged body of matter with a negative divergent charge field and a convergent EM field, along with a convergent gravity field, because all matter has gravity. All matter, in this case charged matter, has a charged field. Generically we can draw it as that. But if we having explained the convergent and divergent forces within a chem or an electrostatic field around a matter body as being net divergent, we can simplify the diagram to net divergent with always convergent gravity on any body of matter. Modelling these two fields, as I've said before, obviously the gravitational field acts on greater distances than that of the electric field. The electric field is more a quantum force with positive and negative charges, a field of interaction, versus a field of convergence or attraction in the case of gravity. As we've noted here, gravity always attracts bodies to the center of the matter, whereas the black body or electromagnetic field or chem field from its motion is an interactive field of positive and negative momenta, and those fields will determine whether a body is attracted electrically or whether it's attracted gravitationally. On a universal scale, bodies will attract each other gravitationally first, but as they get closer and closer, the electric interaction will take place and must be accounted for when you're doing all the force interactions between matter on all scales. So we can redraw, for example, the gravitational field of the Earth as being a body of matter with a gravitational field. Surrounding it, the gravitational field is obviously convergent at all times, acting to the center of the body of mass matter, and it's proportional to the geometry of the mass matter, its size and its mass energy, and it's the result of the vacuum energy seeking to equalize all null energy spaces within the tetrayonic matter that forms it. Equally, the Earth is a matter body moving through space, and it creates its own electromagnetic chem field, which results in this case, a positive bow field and a negative aft field, creating a strong north and south magnetic dipole within the planet, and giving us an electromagnetic field. So, as you approach the Earth, you will first be subject to gravitational forces, which will then become electromagnetic interactions as you approach closer and closer to the planet. And interestingly enough, both the gravitational and the electric and magnetic forces of this complete field all terminate at the center of the planet. In a bar magnet, this will be called the block wall. In relativity or cosmology, it's often referred to as a singularity, a point where all the fields go to zero. We'll explain this a little bit further as we go into it. But mathematically, the interaction between the Earth and, say, the Sun, or the Earth and the Moon, can obviously be mathematically expressed as Newton's or Coulomb's formulation, inverse squared law, or geometrically as the diamond resulting from the superposition fields of both the Earth and the Sun, or the Earth and the Moon. These combined fields at both the quantum and the large-scale cosmological distances are re-termed within Tetryonics as GEM fields, Gravito-Electro-Magnetic interactions. Gravity is always convergent, EM fields are interactive, and they exist at all scales, from atoms or tetrons right up to galaxies themselves. And as this GEM field interaction and the interactive and convergent forces that creates gravitation as a whole, and is the foundation for gravitation, as opposed to the strictly convergent gravity. Again, highlighting once again that all of the universe, both its geometry, its mass, its matter, and its forces, are derived from the single geometry, equilateral geometry, of a quantum of energy, mass energy or energy momentum, or in the case of these drawings, energy angular momentum or mass angular momentum, Planck's constant. Again, when they form matter, these geometries can be re-termed as Higgs bosons for each fascia, charge fascia in the matter. But Tetryonics is the only theory that can explain from the premise of one equilateral triangle with a charge either side everything and every force in our universe in only 3 dimensions. Obviously, as we said, the Sun's gravitational field is comprised of the vacuum energy impinging on the mass matter of the Sun, as well as the radiant mass energy that the Sun itself emits, both through its motion through space as a charged geometry, as well as the mass energies that it emits as photons through the processes going on in its core that convert matter into energy. Obviously, in the case of GEM gradients, just like Einstein's stress energy tensor, these energy gradients can be mapped from the high or higher energy density of vacuum energy to the zero energy density within matter. But just as it's convergent, going from higher to lower in the case of gravity, equally at the center of the star there are higher divergent energies that radiate outwards to a lower energy in the case of radiated mass energies or chem fields from the Sun. So we have a dynamic system. We have gravity always pulling in on matter charges, and in this case the Sun, the matter charge, or even just the Earth, will always possess black body radiation or chem fields that have divergent or net divergent interactive fields. And as we model the interaction between convergent gravitation and interaction EM fields, we will develop a full understanding and a full theory of quantum gravitation. Again, electric fields or charges can be modeled exactly the same way as neutral matter can be modeled, through the diamond shape of inverse squared chem fields that have been superpositioned. And in both cases, the only difference in this case is the strength of the field, with Coulomb's constant being greater than the gravitational constant, and the vector directions of the fields themselves. Again, highlighting that close to a planet or any atom, the electric field, made up of its kinetic energies and its magnetic moment, as well as its black body radiation, is far stronger than that of its gravitational field. The gravitational field works at a larger distance, whereas as you come closer to the body, you have to account for the interactive forces of its electromagnetic field. Both fields obeying inverse square laws. And in fact, they can both be drawn in the same diagram, K being stronger than G, K being divergent and convergent, G being strictly divergent, strictly convergent. It becomes easy to confuse them over time. And this is what's led to another confusion within the previous discussion on physical constants, and throughout I believe quantum mechanics, but definitely throughout electrodynamics. We've explained the role of the alpha constant and the charge geometry in the form of photons, and you can see that they are a divergent form. Using mathematics alone and no geometry as provided in Tetryonic theory, it's been proposed that there exists a particle called a graviton, where the energy momenta points in the opposite direction because it's convergent. And although this may apply in the case of a large field with convergent properties, there is no quanta where the energy momenta in that quanta is reversed. The energy momenta of a EM field is always divergent. It is a charge on one side of the Planck's constant or the other, or one side of mass energy or the other. It is equilateral, and the energy field is always divergent, because charge is always net divergent. So to have a graviton where the momenta of the energy field is convergent is now proven geometrically to be erroneous and just a mathematical dead end. It's possible because of the mathematics. However, the geometry, which is the foundation of the mathematics, shows that that is not the case, and that is not how it works. In order to create convergent forces, you in fact have momenta facing the opposite direction, as in the case of electric fields or chem fields. We've obviously, through the geometry of energy, the equilateral geometry that has square numbers in it, shown that the quantum level or the quantum geometries of Planck's bosons can in fact be used to step us up through quantum mechanics and be applied to Newton's mechanics in the way of kinematics and force equations and the like. We'll now move on, now that we've developed clear distinctions between mass, energy and matter in relation to their geometry and number of quanta in a field. We'll move on to unite both of them and develop a quantum gravity theory. The GEM fields, obviously, again, this is just reiterating that the mass of an object can be recalculated as an energy field, or the mass matter, I should say, of an object can be recalculated as a mass energy field with its energy momenta, the momenta obviously giving it a force component of Newton meters per kilogram of mass energy. And where these fields interact in this diamond-shaped area, again, is an inverse square law, dependent on the distance between the objects. But it gives us a clear way of mapping the force of gravity and the force of electric interaction for any body of matter in the universe, irrespective of its mass energy content and the distance between the objects. That same picture, redrawn as a single body with its own GEM field, is drawn this way. The body itself, in this case the Earth, has its own electromagnetic field made up of energy momenta quanta, equilateral ones radiating out. In this case they're drawn as a two-dimensional, but in reality they would be two-dimensional slices forming a torus shape around the planet with a north and a south pole and Van Allen's belts where the electric fields are. You can then see the gravitational field of the planet is created by the curvature or the energy density of the vacuum energy as it impedes on the mass matter geometries, trying to equalize out the zero energy contents of all matter geometries. And that interaction or that field can in fact be drawn as a diamond inverse squared field of convergent energy momenta from the planet. Although in this case, reality would be that green gravity diamond would not exist. You would only have the electromagnetic diamond of inverse EM field interactions with an additional vacuum energy or gravitational energy density surrounding the matter object. The diamond that's represented here is how you would calculate the force, just as you would the force between two objects of mass matter. Although they are drawn, this is how Newton calculated it as an inverse square law, the diamond shape. In reality, they are spherical mass energies or vacuum energies, higher energies going down to lower energies as the energy seeks to equalize, and in doing so they create this region in between the two mass matter objects, which is the gravitational field region. And you'll see that these fields come up later on in different formulations of gravitational points. The field strengths, obviously, whether you are working on the weak force being the interaction between the magnetic dipoles of energy quanta or charged geometries, or the strong force being the electric field interaction, parallel electric field interaction between charged fascia. Both, or all of them, follow the square energy equilateral geometries of energy that's been discussed ad nauseum in Tetryonics. And it's the interaction between the quanta, whether it's a small number of quanta that are magnetic only in the weak force, or a large number that interact parallel to each other to create the strong force in atoms, or again divergent and convergent momenta within the EM fields that interact to create interactive charge fields, or the strictly convergent force of vacuum energy seeking to equalize the null space within matter, which can be drawn as a convergent gravitational inverse squared field. They are all representations and interactions of equilateral electromagnetic matter energy, mass energy, at different scales. The mass, the weak force, the strong force, the electromagnetic, and the gravitational force all stem from equilateral or tetraionic mass energy densities, or the Compton frequency of quanta within equilateral geometries. The strength of the gravitational field, as we've mentioned before, versus the strength of the Coulombic interaction field between charges, is purely the strength, and it purely comes down to the amount of quanta in those fields. We can represent the gravitational field as the same as the chem field. However, in reality, this field does not exist. It's just it's a geometric representation of the math of vacuum energy impinging on matter in order to get rid of the zero energy density to equalize it out. However, all the same, gravitation still a convergent force to the center of the object, whereas electric or EM forces are still divergent, net divergent, but they are interactive. They can act in two directions at once, close to objects. We can take a closer look. I'll encourage you to do so. When you do the numbers between the quanta in the charge geometry of matter, in this case electrons and positrons of opposite charges, and then work them back into the geometry of the gravitational versus the electromagnetic charge fields, comparing one to the other, you will in fact come up with this number here, comparing the charge constant to the gravitational constant, 1.346 by 10 to the 20, using current mathematics and determinations for the gravitational field, noting of course that the gravitational constant is one of the less poorly known constants in physics today. Looking at the 1.3 by 10 to the 20, we see that, and knowing that inertial mass equals gravitational mass, we can quickly deduce that the correct ratio between the gravitational and the charge interaction, the constants, should in fact be 1.2 by 10 to the 20, not 1.3, an error that the geometry again provides the answer for. We can actually now use that knowledge of the inertial equals the gravitational mass to give us an exact value for the gravitational constant, minus of course any kinetic energy from its motion. Both the coulombic attraction and the gravitational attraction in this case are strictly electrostatic measurements, or measurements of electrostatic bodies, of the force between these bodies, to be precise, between electrostatic bodies, because if either of these bodies were in motion, they would generate an additional chem field which would have energy momenta proportional to its velocity as it moves, and that would affect the calculation of these gravitic and coulombic fields. So again, the measurement should be done as electrostatic particles, and in doing so, and with a knowledge of inertial mass versus gravitational mass and the fact that they are equal, we can correct Newton's gravitational constant to an exact value from theory, as opposed from trying to measure it in real life, where you have the energy of motion interfering with your work. That's what Cavendish was attempting to do in his experiments. Newton calculated the force between the sun and the moon using the ratio of the bodies, the mass matter of the bodies, to determine his gravitational constant. Cavendish then used precise masses on a smaller scale, in this case in a laboratory, suspended on a torsion beam, and measured the rotation between the two bodies as they were trying to interact. Of course, any motion will add energy to a system. Any small charge on these bodies will create a electromagnetic interaction as well. So great care has to be taken, in fact was taken to the limits of his technology, to reduce outside sources of heat, light, magnetic fields, things like that, electric fields, so that he could get the most precise possible measurement. And all measurements to date of the gravitational constant and estimations of its value have stemmed from very similar processes, although increasingly refined in their isolation and in the way that they measure the actual motion of the torsion bar. In this case, Tetryonics, they've given us these two values that you can see here. Tetryonics, from theory itself, can go, as we've done with Planck's constant and the exact value for periodic elements, we can now do the same thing with the gravitational constant, and we can calculate an exact value for the gravitational constant. This picture again just shows the relationship between gravitational forces and electric forces. When measured per second, they are identical in geometry. The difference lies in the number of quanta that would represent each field. In reality, you wouldn't have the diamond shape of the gravitational field. You would have circular geometries of vacuum energy impinging, with the diamond shape being created by the kinetic EM, or the charged E field of the particles themselves. But they're exactly the same geometries, bar for their interactive versus convergent geometries. Again, as I mentioned, we can apply Tetryonics and the knowledge that the ratio between the proton and the electron, the proton's 1,875 times greater than the mass matter of an electron, and equally the quanta in an electron is 1.2 by 10 to the 20, or the Compton frequency of energy momentum quanta that makes up the mass matter of an electron is that amount. We can apply that to the formulations, and we get an exact value for the gravitational constant and an exact value of the force between a proton and an electron at that distance of 1 meter between the two. Change the distance, obviously it's an inverse square field, so it will change. Again, I wish to highlight that even though the gravitation is proportional to the Coulombic constant, and they can both be modelled with the same geometry, the triangular geometry of superposition fields, only the electric field has a superposition field. It's a quirk of nature and a result of the fact that both of them follow inverse square laws, that the radial convergent force of vacuum energy on matter, gravity, can be represented through the diamond geometry of Tetryonic geometry, but in fact it is a radial convergent force, whereas the electric or charge field is the diamond one. And that was the basis of where Newton did his calculations from. Hence why Newton's gravitational fields and his formula looks so similar to Coulomb's formula, bar for the strength of the interactions. They all result and can be modelled with similar geometries. So in essence, Newton can be said to have derived the right result for gravity fields from the wrong geometry, or the wrong understanding of what was going on. However, in Newton's case, he admitted he didn't understand how it worked or why it worked the way it did. He just said that this force between the two objects of mass matter followed this inverse square law precisely, to the best of their measurements of objects at the time. Tetryonics, therefore, at the quantum level, or in this case an atom, can be drawn this way. We have an atom comprised of various nuclei of varying mass energies, from 1 through to 8. These mass energies all combine to give us our familiar periodic elements, and they closely resemble the 4-pi spherical geometries that they've been modelled on over the years, although in this case they're all tetraionic geometries of based from equilateral geometries or tetrahedral matter geometries. All matter creates null spaces within their tetraionic geometries, which, as the matter accumulates into larger and larger elements and matter forms, creates increasing areas or regions of zero energy that the surrounding vacuum energy will seek to neutralize. It does so by converging from the higher energy densities to the lower energy densities and creating a convergent force of gravity onto the object. In the case of static matter, this field here, the chem field, would not exist. In the case of matter in motion, you then have an additional field that is created, the chem field. And this field is its strength and energy quanta in that field is proportional to the velocity of the mass matter in motion, and it creates an additional interactive force when you are close to the body of mass matter. It again follows an inverse square law, predominantly of the E field geometry between it and any other matter surrounding it or coming close and interacting with it. And were this matter to be electrostatic, it would have an additional chem field geometry pointing out the other way. It's been left out in this case purely to highlight particles in motion with a gravitational attraction field and a electromagnetic chem interactive or field of interaction, in order to calculate and develop a quantum theory of gravitation. Both the convergent vacuum energy densities and the interactive divergent and convergent energy momenta of the chem fields or blackbody radiation of matter have to be accounted for. This is done in Tetryonics through the universal field equation and applying the geometry to whatever situation is in place at the time, be it a one-body or two-body interaction, and solving for the final solution to give us our force of interaction between the two in Newton meters squared per kilogram squared. Einstein attempted to do the same thing by applying what he developed in special relativity for the motion of charged bodies to the acceleration, or the generalized acceleration of all matter via gravity. Tetryonics obviously highlights the fact that all mass is an n-pi measurement of energy per second, whereas all matter is a 4n-pi standing wave geometry or energy geometry per second squared, or c to the fourth. Energy by itself is a measurement of the Planck's constant, or the mass angular momenta, the equilateral geometry, and its energy content per second, or it's the mass velocity of an object by the velocity squared. Mass velocity being its momentum, velocity being its motion. So you can have mass, or the energy per second, by its velocity squared, or you can have its mass velocity, i.e. its momentum, by the velocity again. In all cases, special relativity can be boiled down to calculations of electromagnetic fields predominantly, or motions of matter that create electromagnetic mass energy fields. These fields are obviously just flat Euclidean measurements of energy per second, whereas general relativity relates to matter and the fields surrounding it and the acceleration of matter within those fields. So we have to account for both matter geometries in C4's spatial coordinates, plus the superposition of mass energy fields in order to create interactive forces between matter, which again are measured in c to the fourth spatial coordinate systems, second squared. A stylized view of scalar energy geometries. In this case, the energy per second, or per c squared, is mass. Energy is just mass, or Planck quanta squared, or mass velocity squared. It's electromagnetic on the scale as a scalar measurement. It's comprised of bosons as well as scalar energy itself, and if measured longitudinally, is comprised of photons, all of which form a normal distribution pattern. As highlighted to the right, you can see the distribution pattern of 1, 2, 3, 4, 5, 6, 7, 8, 7, 6, 5, 4, 3, 2, 1. That's the normal bell curve or normal distribution pattern that you find in quantum electrodynamics. And in fact, the diamond E field is the field of interaction, and when superpositioned, the linear momentum of the particle becomes a interactive field of inverse square proportionality between two objects, and that is what creates our interaction between charged particles and between matter on the quantum scale. Gravito-Electro-Magnetic fields can also obviously be described in the terms that relativity describes them as, and that is curved space-time. However, the equilateral geometry is far more precise than measuring the energy density difference at any point or region of space, whereas general relativity is often described as a rubber sheet being bent by the presence of matter. That obviously is erroneous, because in order for that quanta of matter to bend the sheet would require gravity underneath it to be pulling it down. That's not the case. What in fact is the case is that the charged geometry, or the folded space-time, the folded energy charge of or mass charge, charged masses of any energy waveform create Tetryonic matter geometries or matter quanta. They then go on to form neutral or charged and neutral geometries depending on the interactive fields of gravity and electromagnetic fields, all determined again by the second law of Tetryonics, and that is all energy seeks equilibrium, whether it's energy in the form of charge seeking to form neutral charges, or charged matter geometries, again charged masses seeking to form neutral masses, or neutral energy geometries of matter seeking to equalize their zero energy internals with the vacuum energy outside them. All energy seeks equilibrium, and that's the driving force, along with energy momentum itself, that moves the entire universe in a cyclical, eternal fashion. Electromagnetic mass is not matter. We've spoken about this on a number of different levels and in different ways, but this page just reinforces that mass is not matter. However, matter itself contains electromagnetic masses, charged geometries of energy. You cannot... The simplest way to remember this is simply that two-dimensional mass energy forms the side of matter as a three-dimensional property, but the three-dimensional property of matter cannot form mass. If you try to... 3D is not a property of two dimensions. These are strictly planar, Euclidean geometries of energy. This is a three-dimensional standing wave form that can be created from these geometries. So you can have mass matter, but no mass energy can have the property of matter. They're distinctions that will be repeated over and over in Tetryonics, because it's such an important point. Again, this just simply points out that the 4 pi generalized geometry of point particles in quantum physics are in fact 4 n pi tetrahedral geometries, be they equilateral mass energies, or tetrons, or quarks, leptons, or baryons, or even elements themselves. They're all 4 n pi charged mass geometries, or charged mass matter geometries. You can represent them mathematically as a 4 pi point particle. However, doing so does not give you any indication of their true geometries, or their electromagnetic function, or the relationship of mass, energy, matter. on the quantum scale. Again, Einstein traditionally viewed mass energy, mass matter, energy itself simply as a energy pressure gradient, an energy density if you like. As you got more matter or more mass or more energy into any region, spherical spatial coordinate system or any measurement of time, the pressure increased, and accordingly the density or the curvature of that region would change. Matter having a higher energy density than the surrounding vacuum energy or light itself, so therefore matter would create a curvature in space-time or the surrounding vacuum energy. Again, illustrated here as a tetration being impinged upon by the vacuum energy in order to create gravity, and the tetration is the building block of all matter. Einstein's formulation goes into a lot of mathematics to describe what he's describing and modelling. Just quickly, I'll go through the geometric equivalents of the four tensor rankings that are in general relativity. The first one being obviously just a straight vector, a force in a line or a line itself from one point to another. It's a rank 0 so far as the energy content or the mass content, which is just a scalar measurement of energy. That's the rank 0 is the scalar measurement of the energy in the equilateral geometry. If it's measured without a time component, it's the energy content. If it's measured with a c squared or a second component to the measurement, it's obviously mass. The square root of the energy obviously is linear momenta going from one point to the other. It creates a vector or a rank 1 tensor, described as just a force from one point to another. A rank 2 is normally used for Euclidean space-time, two-dimensionals, a flat. Imagine, if you like, a electromagnetic field drawn in Tetryonics, cut out on a piece of paper. That would be a rank 2 Euclidean geometric or geometry of mass energy. It also happens to give you the geometry in the case of Tetryonics of electric and magnetic fields, and why, despite them being of equal strengths, they are in fact of different geometries, and why the magnetic field diminishes as in proportion to the cube of the distance versus the square of the distance for the electric. It's a result of their geometry, not shown up in the mathematics. Rank 3 or three-dimensional geometries obviously can be drawn physically with tetraionic geometry. We can show the geometries and the physical properties and interactions of electrons and baryons to create nuclei. These are just represented as rank 3 matrices. Rank 4 being reserved for the curvature of space-time, or the dimensions of energy and time within any the energy density of energy and time within any three-dimensional volumetric region, giving us four-dimensional space-time. Obviously, Tetryonics has now shown that the fourth dimension of time is simply just a misinterpretation of electric charge, which is revealed through equilateral geometry of energy, as discussed as a rank 2 in this case. All the square matrices that you can find in mathematics and indeed in relativity these days are square matrices, 1 by 1, 2 by 2, 3 by 3, so on. All these square matrices again could be redrawn using tetraionic geometry into equilateral geometries of matrices. Obviously, the current generation, having grown up drawing these square matrices, will be loath to change them at this stage of their career and education. However, were mathematics to adopt equilateral geometries for their square matrices, as illustrated in the middle of this page, the end result would be that the matrices themselves would immediately show the results of electric and magnetic field, the electric and magnetic fields within the energy scalar of those matrices, whereas now they're just numbers. Similar, you could generate matrices of any size that would actually represent the physical geometry of energy or mass energy, and again could be used to model many things. And as you looked at one component of the matrix versus the other, you would immediately see the electric and magnetic components of that field, as well as the momenta of that field. As we've mentioned over time, the stress energy tensor in relativity, as highlighted there on the left at the top, is simply just a measurement of the total energy content of any region of space. This can be re-expressed, as I've done on the right hand side at the top, simply as the mass velocity squared, or the Planck quanta squared, or the energy content of any region. Again, using Tetryonics, we delve deeper into the angular momenta versus the energy versus the quanta components of energy. Again, it can be re-expressed purely as the distinction between, in Tetryonics, as the distinction between mass and matter. In Tetryonics, we can then highlight the differing forms of mass energy as opposed to the differing forms of mass matter geometries in that same field, and the interactions that creates. Again, by revealing the difference between mass and matter, we can begin to break up Einstein's formulation of general relativity using tetraionic geometries. We first do so by simply replacing the stress energy tensor by the tetraionic energy formulation for mass, angular momenta, quanta, or mass velocity squared, as you can see there. We then move the formulation for Einstein's constant across to put the measurement of gravitation, of Newton's gravitational formula, to be strictly the energy, the convergent energy per c to the fourth, or a measurement of convergent energy per second squared, created by the tetraionic matter geometry. So we can split up matter, mass, and energy into its various forms, and we can rewrite Einstein's stress energy tensor in terms of mass, matter, and energy specifically, and then move Newton's gravitational formulation to the outside, which more appropriately reflects the true geometry of vacuum energy, creating a convergent force per c to the fourth geometry. Again, just reinforcing that mass, energy, and matter can be explicitly defined in Tetryonics, along with their geometry of the system under study, as opposed to just generalizing them as a stress energy tensor in general relativity. The electromagnetic field tensor in general relativity again can be drawn as the tau geometry of electromagnetic waves or photons. However, if there was an increase of energy from a photon, multiple photons simply become even pi geometries, energy geometries per c squared. And this is important because the per c squared, it is the superposition of one of the photons in one energy field over the other. that creates our fields of interaction between bodies of mass matter. All of this is covered in electrodynamics, and again I encourage you to go back and look through it, but basically everything that can be described via general relativity for the electromagnetic field tensor can be redrawn and re-explained geometrically using Tetryonic geometry. And again, Tetryonic geometry will go even further into the relationships of angular momenta energy, or energy momenta full stop, in both forms, linear and angular, to give us the natural velocity of energy, or the speed of light in a vacuum, which Einstein deemed to be a constant. As I just mentioned previously, all matter has black body or chem energies that result from their motion or their radiated energy from higher quantum levels within their elemental geometries. These fields radiate out from the body, and it is where two fields overlap to create a superposition field that we go from a strictly outward force, or a divergent force of a chem field, to an interactive field of the law of interaction. This law applies to the Coulombic force. However, the same field geometry can model gravitational forces, although it doesn't explain the source or the physics of the gravitational force. You'll note in this case that between two objects of matter, you will have a K, or a kinetic energy squared field of interaction. Both of these fields normally are c squared, or second measurements per second, energy per second. However, where they overlap, they create a c to the fourth, or second squared interaction, with an interactive force between them. The interactive direction is purely determined by the charge of the energy momenta in these fields, and the strength, the number of quanta in these fields. Historically, that's been described in QED as the result of virtual particles. Tetryonics shows it is purely it is a force that is created, interactive force that's created between the energy momenta of both fields. Coincidentally, as we've noted before in the beginning of quantum gravity, the superposition fields with their per second squared units of spatial coordinates are measured in c to the fourth spatial geometries, and that's identical to matter. So by abandoning Cartesian c to the 3 or cubic geometries, x, y, and z components, and using spherical geometries, the spatial coordinate system for both matter and interactive chem fields has been rationalized to both being c to the fourth, greatly simplifying mathematics in the process. This was done purely by using the speed of light as a constant in general relativity. Again, if you were to break up the energy, the superpositioned energy of the chem fields as represented there, you could rewrite them as the square of the mass by the cube of the c. So mass squared, the mass content of this energy field by the mass content of this energy field, by c to the fourth. Again, there gives you the energy field. That again is just the square of mc squared, Einstein's equivalence formula. Again, that can be re-expressed as the square of the momenta by the velocity. Again, there's your momenta, and this is the energy component of the energy momenta equation, or the four vector in relativity. Energy squared, so therefore this part is squared, as is this part. This is the mass component, this is the energy component, and this is the momenta component of a four vector mass energy, or mass energy momenta, mass velocity vector in relativity. Again, highlighting just up here that in Tetryonics we can separate our mass, energy, matter into its various forms. Therefore, we can actually calculate for and draw the rest mass component of any system, the kinetic energy or the chem field, the kinetic energy and the magnetic moment of any field in motion, or its black body radiation if it's just radiating from its elevated energy levels, as well as combining them all to give us the total energy density, or the relativistic energy that this particle would possess if it was in motion at a particular instant of time. This is something that quantum chemistry and quantum mechanics, along with special relativity and general relativity, is unable to do, because it lacks the definition between mass, matter and energy, and the equilateral geometry of energy. So again, this just simply highlights the difference between Newton's formulation of gravitational forces and Einstein's formulation of gravitational forces. Newton saw them as an inverse force between two bodies, which gave him his gravitational constant. Einstein, because of the need to explain Mercury's perihelion and other factors like that, applied special relativity to the task of an accelerating body in a gravitational field, but he, in the process, did not distinguish between mass, energy and matter. He then said that there was no force between the bodies. What in fact it was a energy gradient, or a change in the density of the total energy within that region because of the mass matter, and that the bodies just followed a straight line along that gradient, creating the curve, or the curved space-time as we now call it. Both of them failed to define and distinguish between mass and matter, and that's been the crux of one of the major problems in physics to date, right up until now. This lack of a definition between mass, energy and matter has stymied both mathematics and physics at all levels, both quantum and cosmological, and even chemistry, and led to the extrapolation of mathematical terms without proper geometric foundations into erroneous fields of mathematical science, where we now have black holes and multiple universes and gravity bleeding through from another dimension, all required to explain things mathematically, when in fact the geometry that creates the mathematics is the true foundation. Upon separating the two, we can see that both Newton and Einstein were both right and wrong for various reasons in their reasoning. The maths was correct, but the reasoning was wrong. Newton modelled his as an inverse squared force, when in fact there was no field of interaction between the two, like as in the case of Coulomb's force. Einstein got rid of the force arrangement and redesignated it as a energy density field, but failed to explain what was creating the different forms of energy were, and how they interacted in order to create it. And in fact, he failed to recognize that by using special relativity with his formula for gravitation, he failed to recognize that electromagnetic forces play a part in quantum gravitation. Again, just equating Newtonian and Gaussian formulations of gravity to Einstein, and pointing out that in the case of both of them, they are just the square of a energy density field between two objects, as expressed here and here, and as energy density is exactly the same thing. The energy density, the squared or the superpositioned energy field, creates interaction. The energy density of vacuum energy and matter creates gravitation. And between two objects of mass matter, you get both convergent gravity plus interactive EM fields at work. And until you separate mass, energy and matter from the stress energy tensor, you will never understand why Einstein's formula for gravitation is twice the value of Newton's. Historically, looking back on it, I believe that Einstein came up with his 8 pi purely because he was trying to model the perihelion of Mercury, and in doing so he knew that the answer had to be 8 pi. So he simply put the 8 pi into his equations to get the answer for Mercury, and then continued to use that throughout all the other formulations for his general relativistic formulation for gravitation. In fact, I'll go one step further now that I've revealed the difference between gravity and interactive electromagnetic fields, and show that this is precisely what happened, and in fact that the truth lies between Newton and Einstein at either extreme of quantum gravitation. We'll have a break here, having just covered all the various forms of and formulations of gravitation, and then we'll come back and we'll get into the specifics of quantum gravity or quantum gravitation, and how gravity plus special relativity or electromagnetic interaction combine to give us gravitation as a unified theory.